Hello guys, welcome back to another video. If you look at my videos, my backstory, you'll see that I've been making some gaming videos. And now it's just a switch up because, I've been influenced by mathematics in school. Mainly mathematics. I don't care about school. One day I was in a math class and I set a challenge for myself and I drew a circle and a square, and somehow later that day I proved the theorem. So I want to share that to you guys. So this is called the Kobi theorem. Let me just put this right here. So Kobi theorem. This is named after me. My last name is Kobiashvili. So Kobi, Kobi theorem. Yeah, thank you. In a drawing where a circle is drawn inside a square, the distance between the corner of the square and the point which is on the intersection of the circumference of the circle and the diagonal of the square is always equal to square root of 2 minus 1 times r. So we are basically trying to find the distance between the corner and the intersection of the diagonal and the circumference. This line. And I don't know why I call this Kobe theorem. I could just call this the mini diagonal. I was actually thinking about that. Okay, so first we have to discover that the diameter of this circle is equal to the sides of sides of the square. This diameter is perpendicular to this side and this side. And we know that this side, the lower and top sides, are perpendicular also to this side and this side, the sides on the sides. We can say it like that. This is because the bottom and the top sides are forming a right angle with these sides. This is also perpendicular and this is also perpendicular to the same sides, so they are parallel. And we know that they are contained in the same area, so this diameter is contained by these two sides and this side is contained by these two sides. Therefore this diameter is equal to this side, and we know that this side is equal to this side, so diameter equals to all sides. Okay, now I want to look at the diagonal of the square. We know that these two sides are 2r and this side is a right angle. Therefore, ABC triangle is a right triangle and also an isosceles triangle. This is 45 degrees, this is 45 degrees, but we won't use that in these equations. So, in a right triangle, we know that AB squared plus BC squared, this side and this side squared, equals to this side squared, the hypotenuse squared. And this is a really simple fact. So we can use the calculations, determine that AC squared equals 2r squared plus 2r squared. The 2 is also squared and r is also squared. So 2 squared is 4, r squared is r squared. So this is going to be 4r squared plus 4r squared. And this is going to equal to 8r squared because 4 plus 4 equals 8. 4r squared plus 4r squared equals 8r squared. That's simple math, guys. And now we can just find 8. And we can find AC. It's going to be square root of 8r squared. And if we bring 8 and r squared out of these chambers, it will be square root of 8 times r. Power 2 gets cancelled out by the square root, so it's going to be r. And 8 goes inside the square root, it can't be square rooted. So AC equals square root of 8 times r. Okay, so we know that AC is diagonal and QQ1 are the points on the diagonal. This diagonal goes through point O, and this point O is also the center of the square and the circle. The middle point of the diagonal is always the center of the square. it also gets intersected by the second diagonal, and their intersection is the point that is in the center of the square. It is also the center of the circle, and if we graph these radiuses that are perpendicular to these sides, we can see that this point is r units away from these sides. R stands for radius. So if you say like the radius is 2 meters, the center will be 2 meters away from this side, this side, this side, and this side. And if it's distant from every side equally, we know that this point is the center of the square as well. So we know that QQ1 is a straight line because it's a part of AC line, which is a diagonal. We know that diagonals in a square are straight lines, of course. QQ1 intersects this circle in 2 points, and it also goes through the center of the square and the circle. Therefore, QQ1 can be considered as a diameter. So we proved that QQ1 is a diameter. We can safely say that QQ1 is 2 times R because the diameter is 2 times the radius. And we know that OQ and OQ1 are radii because they come from point O. So OQ1 is the radius of this circle, and OQ is the radius of the same circle. If you go to AJOL square, we're talking about this square, this 1/4 square of this whole square. We can determine what AO is. OQ is the radius of this square, so OQ's radius. AO is half of the diagonal because it gets split in half by this O point. So AO is square root of 8 times R divided by 2. And we have to find AQ, or we can call it B. Okay, so we know that AO is consisted of OQ and AQ. AO equals OQ plus AQ. And we know what these are, so we can type it as AO equals R plus B, which equals to square root of 8 times R divided by 2. We can simplify this square root of 8 times R divided by 2. We know that 2 is the square root of 4, so it's going to be square root of 8 times R divided by square root of 4. The square root will come out. It'll be just square root of 8 times R divided by 4. And we know 8 divided by 4 is 2, so these two will cancel each other out, and we're going to be left with the square root of 2 times R. So we know what AO is, which is half of the diagonal, and the half of the diagonal is square root of 2 times R. So now we can find out what B is. B is equal to this whole line minus this radius. And we know what AO is and we know what R is, so we can just plug in the numbers. B will equal to square root of 2R minus R, and the R will just come out and it will be R times square root of 2 minus 1. So this is the answer. No matter what circumstance it is, from whatever corner you're looking at, it's going to be R times square root of 2 minus 1. Thank you guys for listening. I really enjoyed the video, especially drawing the arcs and the squares and the circles.